Hello everyone, welcome to lecture 5 of CIN708, and this week we shall be looking at infrastructures and sustainable technologies. The lecture is divided into two sections, section 5.1 and section 5.2. MIS infrastructure is section 5.1, and in it we should be looking at the business benefits of a solid management information system infrastructure. Moreover, we'll look at supporting operations, information MIS infrastructure, supporting change, agile management information system infrastructure. In section 5.2, we should be looking at building sustainable MIS infrastructures, and in it, we shall be looking at MIS and the environment, supporting the environment, sustainable MIS infrastructure. Section 5.1, MIS infrastructure. And in this section, the learning outcomes are: explain management information system infrastructure and its three primary types. Identify the three primary areas associated with an information management information system infrastructure. And the third learning outcome is describe the characteristics of an agile management information system infrastructure. MIS includes the plan of how a firm will build, deploy, use, and share its data, processes, and MIS assets. So some of the MIS assets include hardware. A hardware basically consists of the physical devices associated with a computer system. Software, the set of instructions the hardware executes to carry out specific tasks. Network is a communication system created by linking two or more devices and establishing a standard methodology in which they can communicate. Client, it is a computer designed to request information from a server. Server is basically a computer dedicated to provide information in response to requests. Normally the clients are the ones which request details from the server. Management information system infrastructure is generally managed by an enterprise architect. An enterprise architect is a person grounded in technology, is fluent in business, and is able to provide important bridge between MIS and the business. The business benefits of a solid MIS infrastructure continued. The MIS infrastructure support three major functions. First one is supporting operations. Information management information system infrastructure, it identifies where and how important information such as customer records is maintained and secured. Supporting change. Agile management information systems infrastructure includes the hardware, software, and telecommunications equipment that, when combined, provides underlying foundation to support the organization's goals. Supporting the environment, that is sustainable MIS infrastructure, it identifies ways that a company can grow in terms of computing resources while simultaneously becoming less dependent on hardware and energy consumption. Supporting operations. To support operations, the information management information system infrastructure, the following things are taken up. First of all, backup and recovery plan, disaster recovery plan, business continuity plan. All these things, the three components, should be looked at broadly in the next few set of slides. But before we continue, imagine this. Imagine taking a quick trip to the printer on the other side of the room. When you turn around, you find that your laptop has been stolen. How painful would you find this experience? What types of information would you lose? How much time would it take you to recover all of that information? This is why these three components such as backup and recovery plan, disaster recovery plan, and business continuity plan is very, very important in small to medium to large organizations. Backup and recovery plan. Backup is an exact copy of a system's information. Recovery, on the other hand, is the ability to get a system up and running in the event of a system crash or failure. And this is generally done through fault tolerance. Fault tolerance is a general concept that a system has the ability to respond to unexpected failures or system crashes as the backup system immediately and automatically takes over with no loss of service. Failover is a specific type of fault tolerance, occurs when redundant storage server offers an exact replica of the real-time data, and if the primary server crashes, the users are automatically directed to the secondary server or backup service. Failback occurs when the primary machine recovers and resumes operation, taking over from the secondary server. A single backup or restore failure can cost an organization more than time and money. Some data cannot be recreated. Do remember that. And the business intelligence loss from the data can be tremendous. Chief information officers should have enough confidence in their backup and recovery systems that they could walk around and randomly pull out cables to prove that the systems are safe. The chief information officer should also be secure enough to perform this task during peak business hours. Disaster recovery plan. It is a detailed process for recovering information or an information system in the event of a catastrophic disaster such as fire or flood. Disaster recovery cost curve charts the cost of the organization of the unavailability of information and technology and the cost of the organization of recovering from a disaster over time. Hurricanes, floods, fires, and many other types of natural disasters can have devastating effects on businesses. One of the most common types of hardware failures can occur from probably rats or probably mice chewing on cords or cables and devices. Refer to optimal recovery plan in terms of cost and time is where the two lines intersect, the place where you would see an arrow. Organization should choose a backup and recovery strategy that is in line with its business goals. If the organization deals with large volumes of critical information, it will require daily backups, perhaps even hourly backups to storage servers. If the organization deals with small amounts of non-critical information, then it might require only weekly backups to tapes, CDs, or DVDs. Deciding how often to backup information and what media to use is a critical business decision. If an organization decides to back up on a weekly basis, then it is taking the risk that if a total system crash occurs, it could lose a week's worth of work. If this risk is acceptable, then a weekly backup strategy will work. If this risk is unacceptable, then the organization needs to move to a daily backup strategy. Some organizations find the risk of losing a day's worth of work too high and move to an hourly backup strategy. Backup and recovery plan continued. Hot site, a separate and fully equipped facility where the company can move immediately after a disaster and resume business. Cold site, a separate facility that does not have any computer equipment but is a place where employees can move after a disaster. Warm site, a separate facility with computer equipment that requires installation and configuration. Example, this is an example of Union Bank of California. The Union Bank of California has created a disaster recovery plan that includes multiple data centers in diverse locations. It has mirrored sites which can take over at the flick of a switch, hot sites where staff can walk in and start working exactly as they would if they were in their normal location, and vast amount of redundancy. Hot site, cold site, and warm sites are the three types of backup sites that an organization can employ as a backup and recovery plan. Business continuity plan. A BCP is a plan for how an organization will recover and restore partially or completely interrupted critical functions within a predetermined time after a disaster or extended disruption. Natural disasters and terrorist attacks are on the minds of business professionals who take safeguarding their information assets seriously. Disaster recovery plans traditionally contained information on systems and data, ignoring cross-functional and intra-organizational issues for business processes and supply chain management. For this reason, many are turning to a more comprehensive and all-encompassing plan known as business continuity plan. Emergency, a sudden unexpected event requiring immediate action. Emergency preparedness ensures a company is ready to respond to an emergency in an organized, timely, and effective manner. Business continuity planning encompasses disaster recovery plan, business impact analysis, emergency notification services, and technology recovery strategies. All these cater for emergency preparedness. Supporting change, agile management information systems infrastructure. If an organization grows by 50% in a single year, its systems must be able to handle a 50% growth rate. Systems that cannot adapt to organizational changes can severely hinder the organization's ability to operate. The future of an organization depends on its ability to meet its partners and customers on their terms, at their pace, any time of the day, in any geographical locations. These are also called as utilities. Utilities as in ILITIES. So some of the utilities of a business in terms of an agile management information system infrastructure are: one, accessibility, refers to the varying levels that define what a user can access, view, or perform using an operating system. Availability, time frames when the system is operational. Maintainability, how quickly a system can transform to support environmental changes. Portability, the ability of an application to operate on different devices or software platforms. Reliability, ensures a system is functioning correctly and providing accurate information. Reliability is another term for accuracy when discussing the correctness of systems within the context of efficiency IT metrics. Usability is a measure of how well a specific user, is able to easily learn or use the system in which they are very much satisfied. Scalability is a measure of how well a user in a specific context can use a product or design to achieve the defined goal efficiently and satisfactorily. Section 5.2. A solid enterprise architecture can decrease costs, increase standardization, promote reuse of IT assets, and speed development of new systems. The right enterprise architecture can make IT cheap, strategic, and more responsive. Section 5.2 Learning Outcomes. Identify the environmental impacts associated with MIS. Explain the three components of a sustainable MIS infrastructures along with their business benefits. A detailed review of the learning outcomes will be carried out in the next set of slides. MIS and the environment. Moore's law refers to the computer chip performance per dollar doubles every 18 months. Sustainable or green MIS describes the production, management, use, and disposal of technology in a way that minimizes damage to the environment. Corporate social responsibility. Companies acknowledge responsibility to society. The general trend in MIS is towards smaller, faster, and cheaper devices. Gordon Murray, co-founder of Intel is the world's largest producer of computer chips or microprocessors, observed in the year 1965 that continued advances in technology innovation made it possible to reduce the size of a computer chip. The brains, when we talk about computer chip, these are the brains of a computer or even a cell phone nowadays. And while the size would be getting smaller, Gordon Murray also observed that it will be doubling its capacity every 2 years. MIS and the environment. The three primary side effects of business expanded use of technology. These include increased electronic waste, increased energy consumption, increased carbon emissions. Let's discuss three side effects in detail in the following set of slides. Increased electronic waste. E-waste refers to discarding obsolete or broken electronic devices. Sustainable MIS disposal refers to the safe disposal of MIS assets at the end of their life cycles. Gordon Murray's law has made technological devices smaller, cheaper, and faster, allowing more people from all income levels to purchase computing equipment. This increased demand and causing numerous environmental issues. E-waste, like we mentioned earlier, refers to the discarded, obsolete, or broken down electronic devices. E-waste includes CDs, DVDs, thumb drives or flash drives, printer cartridges, cell phones, iPods, external hard drives, TVs, VCRs, DVD players, microwaves, and so on. Some say one human per year is equivalent to 7 years of technological advancements. A personal computer has a life expectancy of only 3 to 5 years, and a cell phone is less than 2 years. Increase energy consumption. Energy consumption, the amount of energy consumed by business processes and systems. Huge increases in technology use have greatly amplified energy consumption. The energy consumed by a computer is estimated to produce as much as 10% of the amount of carbon dioxide produced by an automobile. Computer servers in the United States account for about 1% of the total energy needs of the country. Put in perspective, this is roughly equivalent to the energy consumption of a state in the United States of America. Computers consume energy even when they are not being used. For convenience and to allow automatic updates and backups, the majority of the computer equipment is never shut down. It draws energy 24 hours a day. Carbon emissions. Carbon dioxide and carbon monoxide produced by business processes and systems. When left on continuously, a single desktop computer and monitor can consume at least 100 watts of power per hour. The human-generated greenhouse gases, such as carbon emissions for energy use, are very likely responsible for the increases in climatic temperature over the past half a century. Additional temperature increases are projected over the next 100 years with serious consequences for Earth's environment if greenhouse gas emissions are not reduced. In the United States, coal provides more than 50% of electrical power. When left on continuously, a desktop computer and monitor can consume at least 100 watts of power per hour. To generate this much 24 hours a day for a year would require approximately 324 kgs of coal. When the coal is burned, it releases on average 2.25 kg of sulfur dioxide, 2.25 kg of nitrogen oxide, and close to about 840 kgs of carbon dioxide per year per computer. Supporting the environment, sustainable MIS infrastructure. The components of a sustainable MIS infrastructure include grid computing, virtualized computing, cloud computing. Combating e-waste, energy consumption, and carbon emissions requires a firm to focus on building a sustainable MIS infrastructure. A sustainable MIS infrastructure identifies ways that a company can grow in terms of computing resources while simultaneously becoming less dependent on hardware and energy consumption. So first of all, we'll have a look at grid computing. Grid computing basically is a collection of computers, often geographically dispersed, that are coordinated to solve a common problem. With grid computing, a problem is broken into pieces and distributed to many machines, allowing faster processing that could occur with a single system. Computers typically use less than 25% of the processing power, leaving more than 75% available for other tasks. Innovatively, grid computing takes advantage of this unused processing power by linking thousands of individual computers around the world to create a virtual supercomputer that can process intensive tasks. Virtualization creates multiple virtual machines on a single computing device. Most computers and even servers typically run only one operating system, such as Windows or Mac operating systems, and only one application. When a company invests in a large system such as inventory management, it dedicates a single server to house the system. This ensures the system has enough capacity to run during peak times and to scale to meet demand. Also, many systems have specific hardware requirements along with dedicated software requirements, making it difficult to find two systems with the same requirements that could share the same machine. Through the use of virtualization, computers can run multiple operating systems along with multiple software applications all at the same time. Data centers. Data centers are part of virtualized computing. It is a facility used to house management information systems and associated components such as telecommunications and storage systems. Sustainable data centers, they reduce carbon emissions, reduce required floor space, and chooses geographic location. If we take a holistic and integrated approach to overall company growth, the benefits of integrated information management information systems infrastructure, environment management information systems infrastructure, and sustainable management information systems infrastructure becomes obvious. For example, a company could easily create a backup of its software and important information in one or more geographically dispersed locations using cloud computing. This would be far cheaper than building its own hot and cold sites in different areas of the country. Moreover, in case of security breach, failover can be deployed as a virtual machine in one location of the cloud can be shut down as another virtual machine in a different location on the cloud comes online. Cloud computing, multi-tenancy, tenancy rather. The cloud means that a single instance of a system serves multiple customers. Single tenancy, each customer or tenant must purchase and maintain an individual system. Cloud Fabric, the software that makes possible the benefits of cloud computing, such as multi-tenancy. Why is cloud computing having such an impact on e-waste? Why is cloud computing such an impact on business? To answer the questions, with cloud computing, an individual or business pays only for the services they need, when they need, and where, much as we use and pay for electricity. In the past, a company would have to pay millions of dollars for the hardware, software, and networking equipment required to implement a large system such as payroll or sales management. A cloud computing user can simply access the cloud and request a single license to a payroll application. The user does not have to incur any hardware, software, or networking expenses. As the business grows and as the user requires more employees to have access to the system, the business simply purchases additional licenses. Rather than running software on a local computer or server, companies can now reach to the cloud to combine software applications, data storage, and considerable computing power. To explain the associated benefits of cloud computing, these are on-demand self-service. Users can increase storage and processing power as needed. Broad network access, all devices can access data and applications. Multi-tenancy, customers share pooled computing resources. Rapid elasticity, storage, network bandwidth, and computing capacity can be increased or decreased immediately, allowing for optimal scalability. Measured service, clients can monitor and measure transactions and use of transactions. Cloud computing generally offers its services in three main ways. First one, infrastructure as a service. Infrastructure as a service delivers hardware networking capabilities, including the use of servers, networking, and storage over the cloud using a pay-per-use revenue model. Software as a service delivers applications over cloud using a pay-per-use revenue model. Platform as a service supports the deployment of entire systems, including hardware, networking, and applications using a pay-per-use revenue model. There are four primary cloud computing environments. These include public, private, community, and hybrid. Public cloud is open to all to store and access information via the internet using the pay-per-use or pay-per-usage method. In public cloud, computing resources are managed and operated by cloud service providers. Private cloud is also known as internal cloud or corporate cloud. It is used by organizations to build and manage their own data centers internally or by the third party. Community cloud. Community cloud allows systems and services to be accessible by a group of several organizations to share the information between the organization and a specific community. It is owned, managed, and operated by one or more organizations in the community, a third party, or a combination of them. Hybrid cloud. Hybrid cloud is a combination of the public cloud and the private cloud. The services of both public and private cloud are offered in a hybrid cloud system. Thank you very much for listening. This finishes Lecture 5 for CIN708. Thank you.